going to show you three devices. These are prototypes of technology which enables you to generate high voltage, high current, and basically DC with a slight frequency around 5,000 hertz. These devices will generate this electricity without the use of any fossil fuels or any power source of any kind that needs to be replenished. These devices have been in operation on and off for a number of months. This particular device here weighs about a pound and a half, and I'm going to energize it now. And what do you feel in the unit now that it's in operation?
Buzzing, vibration, slight noise.
Vibration.
Yeah, vibration.
Nothing serious, kind of a slight gyroscopic effect in the air. The unit itself is size-wise about 5 inches. The unit is dead exact at 6 inches. It's about 2 inches tall. About 3/4 of an inch thick. So the voltage meter is automatic. The unit is putting out a fluctuating voltage. It's 121.8 volts, I believe. Stabilized at 121.8. The voltage will vary between 110 and 145 volts in operation. So we know the voltage. Now let's discuss the current. This device is capable of putting out up to 5 amps of electric power at 100 volts. Show the current now in operation. We'll use a light over here. Use a lamp already lit. This is a 100-watt bulb in this lamp. I'll show that. Now, a 100-watt light bulb at 100 volts would be 1 amp of power. So I'm now going to plug it directly here, and voila. You have 1 amp of electrical power. Actually, more than 1 amp of electrical power at 127 volts. Power this light bulb, which is extremely hot to touch. Following this out, we have the unit itself. Wires straight over here to this lamp. Now, there's no battery in this lamp, obviously. Certainly no battery small enough to create this kind of electricity. However, I will now show a unit that is even smaller than the first one. This unit is a little less than 4 inches. A little less than 4 inches. And it's a little less, it's about 1 inch and 3/4 tall. So it weighs about a pound. We'll activate the unit now. Let's measure the voltage again. This particular unit puts out about 100 volts, right around 100 volts, 100.8 volts. A little smaller. It'll vary between 95 and 115 volts generally. This is a 100-watt light bulb again. obviously, it's a base receptacle. No possibility of any kind of batteries in here. And with the aid of these two alligator clips, voila. Oops. There you go. Another unit that is generating an amp of electrical current. Very, very, very slight vibration of the device. Lower current. There are physically no batteries capable of producing this much current at this voltage. It's obviously being generated by the devices themselves. These are inherently high voltage devices, and they only produce DC with a slight frequency of around 12,000 hertz. Let's go over here and look at the largest device that we have. This is the largest device that we have made so far. This particular device is measuring about 17 inches in diameter. It's about 3 inches, a little more than 3 inches in depth. So, turn on the primary frequency, and now the secondary frequency. The unit is now in operation. There's also a slight vibration in this. However, very interesting effect. Paul, if you'd like to touch that. Now, slide that back and forth with your hands.
Much less vibration than the smaller one.
Less vibration than the smaller one. Okay.
But it's a tingle there.
Okay. What is it doing?
When you move it, it feels like you're pulling it across a washboard. It doesn't want to go.
Right. It resists movement.
One step at a time.
Exactly. Each time the frequency comes together, it appears to have an effect. It's like a gyroscope. Perfectly solid state device, no moving parts, just the vibration as the device is in operation. Let's measure the voltage. This gauge is set at 1,000 volts DC. The unit is putting out 830 volts DC. 830 volts direct current. That is enough to kill a man easily at the right current. To show you the current, we have set up these lamp bases here. They're just wired in series. Each one of these lamp bases is wired in series. No possibility of any kind of batteries or any kind of trick in these devices. These are brand new 100 watt light bulbs.
now is 100 watt bulb.
I found another 100 watt light bulb. So we have 10 100 watt light bulbs. Unit is in operation. Now looking at the unit producing several amps of electric current. 870 volt DC system. The unit will power more than 10 100 watt light bulbs easily. And here, the current gauge. Current gauge will measure the amount of current that's being produced inside the unit itself, inside the coil. Fluctuating voltage and current. 1.23 amps here. 1.23 amps at 870 volts is quite a bit of power. That would be at least 8 amps at 120 volts. Can be used to power aircraft, ships, automobiles, homes. At the present time, the units develop quite a bit of heat, which also could be captured to produce additional electricity. These units could very easily replace atomic reactors for power generation. Quite warm. This is the basic equivalent of an electric heater. We're looking at 100 times 10 is 1,000 watts of power. So this unit easily generated 1,000 watts of power, and I assure you we do that all day long.
I've heard that some people question whether there might not be a battery inside of these devices. Can you tell us about that?
Yes. I've shown this to multiple engineers, and they never question whether there's a battery involved in this at all, simply because of the physical size of the unit. A battery capable of producing 1,000 watts of electric power would be quite large and quite heavy. A lead-acid battery capable of producing this much current for this period of time probably would be about 24 inches by 6 inches by 15 inches. High voltage batteries are very rare, they're very large, and they're very heavy. If this were a battery, it would be an entirely new kind of battery and would be quite valuable simply based on the principle of being a battery. There are no batteries known today that have this performance, are capable of lighting and putting out this much power. 1,000 watts like this is basically an electric heater here in operation. Is what it basically is.
And there are no batteries in the unit.
No batteries in the unit, no batteries in the base of any of these lamps. So it's quite a bit of power being produced by a device that is way too small to be a battery. Or have batteries in it.
Thank you.
Because they can cause serious harm because of the amount of power that they produce. The same thing that comes out of an outlet on the wall.
Even though it's called the same. You know, the power on there is really. So if you'd like to bring it,
This is a standard
Meter.
standard voltmeter. Yeah. We're going to remove this now. So as I say, you please don't touch those leads. You'll be remembered for a long time. Here you're looking at right now basic optical very good. 183 volts. Yep. It was a constant. It'll vary a little bit. Stay right around 183 volts. Yes. If you would be, this is a 100 watt line volt, 120 volts.
yeah.
So you're looking at at that voltage, you're looking at a bit over an amp of electrical current.
Also, if you're going to be the man that's going to hold the bulb, okay? Yeah. Okay. Just hold it on there for a second.
All right.
Okay. It's getting warm. It's getting warm.
It's a real bulb, and
Okay. Now what we'll do is hook the generator to the inverter because being a, we've got to bring it down 110 volts. Yep. System here. Is that on the power that they were
yes. All right. The standard television. I'm sorry, I just want to show you this.
We've got to get it tuned up
yeah.
right.
We wanted to make sure that it works with these antennas on top of it.
And so that's basically dropping down 110 volts in the drive. The normal cycle is 5,000 volts, so that's the drop of right and invert. Not a very good picture there. What is it?
Sorry about that.
Anyway, at least you can see it's power.
Yes.
So it's power, no problem at all. So that's the power there. Now what we're going to do is hook the electric fuel through in there and the plug.
This is rated at 3 amps at 145 volts.
Okay.
And
The next thing is to do the vacuum spring in there.
back here, this has an 8 amp draw when you first plug it in.
Yep. Now, what we'll do now, they're going to take survey power businesses. Okay, that's good.
Okay, but
It's like a fire. But it's a fire, isn't it?
Yeah.
It's not an arc. That's good, Stephen. It's fine. Okay?
More nice.
You feel that resonance, Will?
Yeah, that's fantastic. Thank you so much.
You're welcome.
What's your name about
Bigger.
We have that series.
Yeah.
Yeah. Anyway, the unit is in operation now.
It's operation now.
Here's a standard voltmeter. I think the indication will be clear.
It'll fluctuate a little bit, but
So anyway,
right around 180.
that's enough to give you a little bar that can fill you.
But you said it's operational now, is there a connotation that it's sometimes off?
Oh, no, we've got it going operational, but, you can turn it off. Oh, yeah, you can turn it off. So,
Well, this is set up to be turned, so that it can be turned on
you
or off?
can, this particular one, yes. So these are what we've done.
This one cannot, this one's just on.
Oh, this is on, yeah, this is designed without all the other things like that. That's the later one. All that right, bro.
Standard 100 watt light bulb. We're looking at obviously.
Right on. When you bring it.
I know, it's getting warm, that's why I took it off.
And Brian, I heard mention that the output is hybrid.
Yep.
Eventually.
Okay. Oh, Hey, this thing is this our antenna played a very important role.
We finally got the antenna to work right.
But I didn't
Played
feel
with it for 15 minutes.
we had more trouble with the antenna. Exactly, yeah, that's why we always do it. Anyway, you can actually see it.
3 amp electric drill, which will This is a vacuum cleaner, which draws up to 7 amps basically on starting very different indication of the kind of power that this. This is so this is all everything that's in here is just designed to do nothing but put out sine waves to operate the line.
Exactly.
That's all good. Over here,
What we're gonna do is we'll move it down to the large.
at this point, I ask that you be extremely careful.
This is a very powerful unit.
Someone was very seriously injured with this unit at one point. And so, let me see. You may want to remove the rings and wristwatches, please, if you have any on. It's for your own safety because if accidentally you were to make some kind of electrical contact with the ring, it would burn you very badly. So I wouldn't want. It's safe, but that aspect. We're demonstrating.
That's normal procedure.
We're
Working
demonstrating
around electricity.
extremely high amounts of voltage and current that can kill you. So
This is that washboard phenomenon I was telling you about. As you live, you can actually feel these sort of resonance.
this unit is in operation, and we'll measure its output, which I'm really not certain of right now. It is about 874, 75, 870. 875 is going to be probably where it's going to be. Yeah, 875 volts.
A lot of muscle.
And
And what all am I looking at? This has some additional components to it? Or is it bigger?
This is just bigger.
So this has all the same?
In miniature. Miniature, that's all.
but if you hold it only on the black tape and slide it don't push down, just slide it back and forth very slowly.
Feel that resonance.
You'll feel, yeah,
What
resonance.
Feel that, huh?
I could feel it. I
Yeah.
was trying to determine the difference between friction here
Okay,
and...
that's it. Yeah, you can actually feel it.
So what is it that I'm...
So you're breaking the magnetic lines of wood as you're pushing it across.
And I would be able to feel the same by moving them, that smaller one?
They all produce resonances, but it's difficult.
Sometimes they're very subtle,
That's
very
one,
subtle.
right? Yes, you may go ahead as well. Stay away from this area right there.
This is actually very, very hard. Can you do it?
Be very quiet.
Very
Don't produce any pollution.
marvelous.
But you know, it's not magnetic...
Nothing at all. The expert, the EMF of this last time we measured was only 0.1 of the baby one. And the TV was 12.
You feel it.
Yeah,
That's much more than
yeah, for sure.
It resists moving. That's what it's doing.
What?
Stand on that subject. You have your current
Yeah.
that they're licensed to put out.
What?
Yes.
1000 watt light bulb, just in series, see? Wide series.
Yeah, each bulb would represent 1 amp.
And it's a kilowatt of sound. Okay? One, two.
Yeah, so if you're looking at a small electric heater, well, a basic electric heater for a home is what you're looking at right now.
Fantastic spirit. Okay.
You wanted to just,
Yeah, that'd be nice if you have to.
to show the way.
What we're going to do is, you'll find that there's sort of a fire, it's like a flame phenomenon on this.
Showing you. That's not good.
Oh, true. So it's like it's not like a normal arc, sort of a fire.
You get a very severe burn if you touch it.
Oh.
But if you get out there too, you grab those things, it won't be fun.
Sort of, how was that getting when you were... Was that getting...
Oh, yeah,
very
it'll
hot to your
burn
hand?
your finger.
I mean, the connector in your hand.
Yeah. But there's one more thing I wanted to show you. It's this over here. And
What we're going to do here, we're going to depower it by 90% because that, it'll kill you, so we're going to give it off. So it's like taking
power, you're taking some
You
of the
take-
coils out of...
We've actually turned part of it down. Okay, we've turned part of it off. So now you watch this flame I was telling you about.
it's an 8-cylinder automobile running on 1 cylinder now.
Correct. That's right. Okay.
I get a little
So you guys just relax.
One time we made a mistake and it wasn't powered down. At the time going on.
Well, we already got it. It's like a fire, not like a normal ash. Okay? It'll melt those things.
But it's not moving metal from one contractor to...
Well, you see, well, of course it will be going like that.
Oh, for sure, you know,
Well, but this is doing that.
you will, that's all.
But, see, straight standard DC, of course, won't arc like that. And high frequency, in fact, if you notice the TV monitor, it reacts because it's a high frequency arc.
Is it rolling in here?
It's rolling.
Yeah, it rolls there because
But we can
speed
focus
of the...
it.
Yeah.
If we get
All right.
it there, it's nice.
That's it. You can turn it off. Okay. Good on you? All right.
Yeah, there's 5 minutes.
Good job.
Yeah, thank you.
The whole thing.
So when you're actually drawing current off of the any of the rest of the heat up?
Now, we'll do eventually, in these little models, they sometimes warm up factory, but in the future, they'll be factories. Anyway.
Thank you. You're watching the spring back.
I'll go here and call it one. Thanks very much. Thanks for Stephen Cole. Thank you. I'll give him the phone later on. Thank you. Well, we got it. It's not got you. There was any shot there of this. Yeah, sorry, you don't use it, but finish the position.
I'll see what's here as well.
As long as you can get it all in and back. Stay steady.
It's very steady, all right.
Now, my variety and some of it on the crude.
Like I said, let me do my demonstration over, and then whatever is on my time at this point, we'll deal with. Did you want to check the perimeter before we did your field measures on? Well, you just want to set it up all over the operation? I don't think that, well, no sense to find out the thing in operation because you get very easily as something turning on and off. I don't know why. Remotely. Why this is going on. Is there a basement? No. Well, do you feel that the power lines are fine? Well, I don't make a measurement regarding the power lines. Are you sure it's not good? Yeah, but where's the plastic? Because I noticed that it's not if you don't. I'm not sure I can help it. Oh, no, it's the only way to go. Once upon a water,
Two 2.2 millivolts. I'll just go along. Yeah.
Which is what sort of?
Well, I have to determine that later. This.
Choose the highest.
This field, what it does, it's only going to do it for just a little while once it energizes, okay? And then, so I want it to pass quickly because it'll quit and then no one will see. If that's all right. Right? Oh, and be very careful of these leaves.
Yeah,
Feel it? Be very careful. Just lay it flat.
You can feel that. You can feel that. You can actually feel the resonance in the coil.
Be very careful of those.
You give it 100 volt boost.
Okay, Mr. Dorian?
I haven't taken any.
No.
There are two leads right here.
I don't care. Take all you want anymore. Notice it has a slight gyroscopic property to it, by the way.
Yeah.
Isn't that unique?
It's true.
Huh? Got a pulse in it? Huh?
Be very careful.
No, that's all right. That's all right. It should have stuck on there. There's not one. Let me see this. Let me check. As an example, if you touch this here, and let's see underneath. Well, put your hand right here. Feel the heat coming? Put your hand right under here. Yeah. Feel the heat coming? What's the problem? A bit. Oh, wow. Yeah, notice, look, it's dim. See? Now, when you turn it back, it's affected by being...
Tilted with the magnetic
Right,
field.
yeah. Sometimes if you put a magnet, well, no, isn't that...
27.5 minutes.
If you keep adding minutes, you'll get an idea of exactly how many minutes it's been in operation overall. You know what I'm saying?
How's the temperature on that thing?
Well, it's very hot. It will burn you, but I'm going to see if it'll get a little cooler with a negative 5.
Yeah, this way. Oh, here we are. 146, 147.
By the way, another thing, the voltage will vary up and down. And interestingly enough, it's usually in like intervals. Like every quarter hour. It will, in operation, it would be 150 volts. And then you'll turn it off and you'll turn it back on again, and it'll be 110 volts or so. And it goes up, down, and down. In operation, it will go down, and then it'll come up rather quickly, and then go down again. I have no explanation for that either, other than it must be the effect of this. Then see, look, it doesn't just...
No, got disconnected.
Oh, I'm sorry.
Yeah. What are the reading volts? Reading around 80.
Going down.
Started at about 90 and it's going down to 80, 72. But now,
I wonder if this... Now, I would like to ask that no one touch this unless as I tell you to touch it, okay? Because this can put out quite a bit of power, and I don't want anyone to get hurt in any way, okay? That's a big one, huh? you'd like, if you push on this gently, you'll notice that it produces a resistance to your movement. If you'd like to. The same kind of thing that the other one does, only it's a little bit. This way.
Washboard.
Yeah.
What is it? Washboard. How do you feel it?
Do you have any theory on that?
No. And yet it is.
It's interesting.
You can actually feel that.
I agree with you.
Mr. Doran, excuse me a second. Yes, I put it on a.
You feel that, Nick? Look at the camera and throw it aside, don't you?
Yeah,
Can you feel that?
quite a bit of resistance.
You can feel a little resonance, can't you?
Yeah, feel the resonance.
Why I'm not necessarily certain, but I mean not fast, but it definitely.
Yep.
It jumps up, and I don't understand the jumping up, but when it does that, that's
Well,
really.
that would be due to some other effect. It wouldn't be the coil. It would be any electronic device or any battery source you may have for signaling or measuring or control purposes that could be there.
Now that's another thing I wanted to mention. $2? Maybe you want to connect it to. Actually, I think it's better to put it on. Oh, you're, I see, okay, very good.
Now the voltage.
That would be 179, 78.
Shall we increase the load? See what happens?
Sure.
There.
181, 180. Would you mind if I performed one little experiment of my own here? Sure. I would like to see what happens when I remove this. Should not be. Because usually you can energize it and remove the magnet and it doesn't, isn't that strange? Well, for me it's strange. I don't, it's not working properly. I really apologize. Actually, because it's not,
Well,
789, still 789. This is the one that the voltage drops and then sky high, and that's not a very. A couple of those there, Mr. Richardson, please.
Are you handling that one?
one more voltage.
I'm taking those.
Well,
I'm taking everything that moves.
probably going to be pretty good. And then the blue wire from there. Oh, I'm sorry. Well, as the French would say. I didn't mean to. 456, 460, 61, 459. Would you hand me a magnet, please?
They ordered them.
How about that?
What's it say?
No, it's this one. I think it's 400 down.
That's when it starts up again?
It goes sky high. Very, but that's they have, each one has its own characteristics. Do you have a laboratory?
Mm-hmm.
Because, boy, if only I had the proper equipment and someone to help me, I think I could create, do so much of these things that I have.
No, you get right down, probably right down. Yeah, I'm going to go down. Or maybe,
But it isn't my day, is it now?
yeah, it's a bad day.
I just realized it isn't my day. I want to show one other little thing, by the way. I'm sorry. You notice that it's about 2 inches of
Yep.
and that's not,
Right, yeah.
that's from the frequency.
Yeah.
So, when the main coil is connected, it is more of a bang, but I don't do that because it's not it shows nothing but sparks and a loud noise. But you can get the idea of the frequency being present here. And it is around 5,000 cycles. That's worth it 60 times a second, creating a magnetic field that moves. You know, magnetic fields move out away from the wiring, right? That field could couple directly to an electron flow in this coil. Okay, so that would be a way of generating electricity here, so it would look like there was power coming out of this. That would not be the case. I mean, in this case, it can't be because we can move this around. Obviously, there's nothing under this table and there's no wires going to it. The other thing is, like our government was interested in doing, you can collect energy from someplace else and send it via radio waves. Microwave transmission is an example. You could line of sight beam microwaves to a collector and light a bulb. I have talked to engineers and they've told me that the amount of power to do that, to light one bulb, is pretty astronomical, and it would be dangerous. And the other thing is that it has to be absolutely line of sight, straight down. The other thing is a gentleman from radio engineering here in Anaheim, California, he did some calculations. He said the collector for it would be about 4 to 5 feet in order to be able to. The other thing is that this gentleman will probably tell you that this is not a microwave device. Because it's just not a collector. There's no way that it could be anything like that. But those are the things that you would have to look for in dealing with something like this. Change how the amount of effort in spinning. That to me is interesting because if I'm wrong, I mean I probably am, but I'm saying, doesn't that mean that the potential exists for it to develop some kind of a motive force, no matter how small? I mean, it's just the possibilities. And there's one other thing.
I'm getting a reflection on your bald head.
This is the part where I say I don't have my sleeve.
Don't worry about my bald head. You see what I'm doing this thing.
You have to understand that it takes a great deal of time to construct one of these devices. I'm talking months.
Yeah.
Because and you want to talk about patience? I have no equipment to work with. You're right.
How they feeling the temperature over this?
You know what? It's not. You're right. See, this is not. Well, it's supposed to put out 500 volts. Now, if it's supposed to put out 500 volts.
That is no.
No, on the inside. Okay.
Of course.
It's going to right now.
What's it putting out?
800? Let me see. Oh, here we are.
There we go, 149.
No, that's the voltage.
149, 148.
148 volts. 0.5 amps. And the watts, that's where it doesn't, you know, like, there's something not correct here. Yeah, so, that means 0.5 roughly, and 142 roughly. Okay.
Well, I hope it was worth it. You spent a lot of time doing that.
No, worth, that's the money.
Here. Both of these.
You stop putting up there now.
I should say.
You wouldn't be mucking around in the Ricky.
I just want to make sure I.
Someone put it over 100 volts, did it?
I'm going to move over here. You may. I don't want anything shorter edge here. Hit something. Success. Probably right.
You end up putting it through your shaft with like this. It's pretty shit.
My mom was always worried about me hurting myself in the garage. So it would do for me to do it today.
Thanks, Bill. They're quite light.
You know, you people are positively Japanese. you take, you know, I showed these devices to a Japanese lady, and we had an assistant with him, and they photographed absolutely everything. But he was the most polite gentleman I've ever seen. He was such a nice man.
Well, you know, apart from the truth, I was born and raised in Japan.
Oh, really?
Yes. There for 23 years.
Do you speak Japanese?
Mm-hmm.
Oh, goodness. Oh, that's nice. That's a difficult language, isn't it?
Well, it's easy to get to speak, to get around,
Oh, in another language.
but it is very difficult to get to.
Bill's camera good to use it? That's right. About 70 degrees. 123 degrees Fahrenheit.
Oh, I haven't taken any. Can I just look at that voltage?
Sorry, just degree Fahrenheit.
Okay, it's starting to smoke now. This is generally. It took me probably 6 months to make this.
Yeah.
So I don't like to just let.
No,
them
no,
go.
absolutely.
I only have 3 left. So
Don't get electrocuted.
I know.
Positive, negative would matter.
No. Not on the light bulb. Switch. The magnet. Well, that magnet is. You keep adding this, you get an idea of how exactly how many minutes it's been in operation overall. You know what? You know what I'm saying? Well, it's very hot. It's burning, but I'm going to see if it'll get a little cooler with the magnetified. Sometimes it does that.
Let me see now. Yeah.
You might want to observe this. I've never had the chance to do this. Magnet. That's funny. The magnet must affect voltage, but not current. That's very interesting.
Yeah, it's that takes you here the actual thing. Well, it is a current. If you move it there, it will go up again.
Yes, you're right. It does. You know, another thing is...
Well, part of the reason that the current is going down, it's difficult to make this experiment this way, is that the light bulb is getting hotter and the resistance is increasing. Okay, now can we just measure the voltage? Okay.
By the way, notice that the voltage will vary up and down. Interestingly enough, it's usually in like intervals. Like if it's every quarter hour, it will, in operation, it would be 150 volts. And then you will turn it off and you'll turn it back on and it will be 110 volts or so. And it goes up, down, and down. In operation, it will go down. Come up rather quickly and go down again. I have no explanation for that either. I mean, it must be the effect of it. Then,
What are reading volts?
Yeah, started at about 90 and it's going down to 80. But now,
if you like, if you push on this gently, you'll notice that it produces a resistance to your movement, which is actually kind of thing that the other one does, honestly. Washboard. Yeah. What is that? Washboard. How do you do it? It's not correct. It's not supposed to be functional at 2 volts. I don't, and when I remove the magnet, it shuts off and goes to 40 volts. I don't understand why it's doing that.
Unless it's working at 200, it's supposed to be 240 or?
No, this is about 500 volts.
Oh, hi.
So I'm a little, I don't understand why it's not working right. We can try to test it at 200. That would be probably 2 light bulbs. That's right. I think it's better to do. Oh, I see. Okay, very good. Maybe 179, 78. Shall we increase the load? See what happens? Sure.
You have to open it wide. Cross that.
181, 180. Would you mind if I performed one little experiment of my own here? Sure. I would love to see what happens when I remove this. Should not be. Because usually you can energize it and remove the magnet and it doesn't, well, for me it's strange. I don't, it's not working properly. I really apologize. That's 78. Yes, but I feel badly if it's not working the way it should. I feel very badly because it's not.
Well, we've seen it. Why don't we connect that one?
Oh, I'm sorry. Well, as the French would say. I didn't. 485, 478, 71, 65, 67, 66. That I was having before. April? Oh my goodness. I had these magnets in the pocket with my wristwatch. Does that explain? I thought that wasn't very fiscal. Oh, no. Oh, dear. How about that? No, it's steady at 438, 436. Doesn't seem to be making sense. 400 now. It goes sky high. Very, but that's when they have each one has its own characteristics. Do you have a laboratory? Because boy, you probably have the proper equipment. You know, do so much of this.
No, we went down. How did we go down? Oh, okay.
Well, this really isn't my day. Nothing seems to be. No, by God, it isn't my day, is it now?
Yeah, but that's it.
Just realized it isn't my day. I want to show you one other little thing. It's a like a high frequency discharge. If you're familiar with this, and I just want to. You notice that it's about 2 inches of and that's not that's from the frequency. So when the main coil is connected, it is more of a bang, but I don't do that because it shows nothing but sparks and a loud noise. But you can get the idea of the frequency being present here. And it is around 5,000 cycles. As I said that, apparently, enough that it's not a secret any longer.
Is that a lot of that?
Excuse me?
Is that a lot? 5,000 cycles?
Oh, no, not at all. According to that clock, it's about 12
Being on just over 12 minutes.
just over 12 minutes. Okay. And I'd like to tell me if I'm wrong, but there are several ways that you could put power in here.
Tell me what it is.
This is zooming in and out.
Where do I press?
I'm just
Button.
having it's on there. I'm just zooming in and out of it.
You're going on the back now. Is it on working now?
I don't want you to look at it. You slide that away.
Is it?
Well,
This thing's working now, is it?
there's something else, by the way. Remember I told you I had it sitting on a rotating, reverter? As you change the load on the device electrically, you change the RPM, you change the how the amount of effort it's spinning. That to me is interesting because now if I'm wrong, I mean I probably am, but I'm saying, doesn't that mean that the potential exists for develop some kind of a motor force, no matter how small? I mean, it's you know. It's a possibility. There's one other thing I want to do, by the way.
Hey, can you do it? We do a picture.
I'm getting a reflection on your bald head.
This is the part where I said I hung up my sleeve.
Don't worry about my bald head. Just go around like this.
You have to understand that it takes a great deal of time to construct one of these devices. I'm talking months.
Yeah.
Because, and if you want to talk about patience, I have no equipment to work with. I have to sit down for 8 to 10 hours a day for months to be able to make one of those things.
Steve,
No, I'm telling
Oh,
you.
the mate,
I'm telling you,
there's a lot of it.
Trying to find a, Now,
Yeah, take over.
how long have you been on?
Just want to take that one off and end it.
20 minutes?
16 and a half.
It's being really stable.
Look, Doctor, you've taken the magnet away and it's still producing the voltage.
But we use the magnet only to
Charge it.
start it.
But you remember I was having problems with this
Yeah,
one?
yeah.
And I had to leave the magnet on it? Well, now I've taken the magnet away and it's producing the 200 volts it's supposed to be producing. I don't know why that is.
Using more now.
More what?
More volts.
Oh. No, I mean, it should, no, it was putting out around 200 before. Yeah. And
What should that one put out, Stephen?
this 500 volts. There's something wrong with it.
Would you permit me to look at the field? This here is still the same as was when we started.
Is this the device that measures the
Yes, just a switch coil. Yeah.
You know, I know you're a very busy man, but someday I would really like to sit and talk to you. If you ever tried that?
Stephen, you wouldn't know the effort we went to find the doctor.
Hot here and hot here. You're right.
When you have a feel for it, I've been feeling the temperature all this
You
time.
know what? It's not. You're right. See, this is not. Well, it's supposed to put out 500 volts. Now, if it's supposed to put out 500 volts, that has no. But you didn't functional gravity. No, it is hotter.
That day's coming off here.
No, no. You see this? You find little parts of it that get hotter than other parts for some reason.
What sort of reading are you getting, Ronald?
Well, the field is mostly confined in this ring.
Can I see your meter? Can you show it to me? 1.5, 1.8?
It automatically comes on. This is what it was before.
1.7 millivolts, isn't it?
Yes.
Millivolts?
You
Yeah.
get yours as soon as I can.
Let me just zero in on that. Yeah, okay.
Well,
What's happening there? It's gone up to 800.
What's it putting out?
800? Let me see. Oh, here we are.
On the wrong
That's
scale.
it. Yes.
149.
No, that's the voltage.
149, 148 is the voltage.
48 volts. 0.5 amps.
52 amps.
And the watts, that's where it doesn't, should be more like
763 watts.
something not correct here. Yeah, so that means 0.5 roughly, and 142 roughly. Okay.
There's your pad there. Well, I hope it was worth it. You spent a lot of time doing that. No. Work, but
Stop putting it down now.
I should say.
You would be mucking around in your week.
Yes. sure I...
Then we put in over 800 volts.
I'm going to move over here. You may, I don't want anything, pieces of metal to hurt anybody or anything like that.
No, but,
How about the wall flippers right here? The saw blade wasn't designed for this.
You take some photographs of that thing all chopped up.
yeah, a little bit, I'll take you store it. Yeah, so we put on bits together.
Some of the wiring came out of the inside of this one, so... Stay out there? All right.
What are you reading now? Voltage?
2 more.